Today's session. Today we'll be discussing about orchestrating external data sources for informed decision making. I'll be presenting it with Thiaga Mania. So before handing it over to Thiaga, let me introduce myself. My name is Raja Chattopadhyay, and I'm senior manager of software engineering in Capital One, working with Capital One for last 10 years, and my main technical expertise are data management, cloud infrastructure, and API orchestration. With this, I will hand it over to Thiaga.
Thanks, Raja. I'm Thiaga Manian, Director of Software Engineering at Capital One. I'm part of the Data Engineering and Analytics organization, and my teams work on real-time data ingestion and large-scale data processing. Um, Brief intro about Capital One. Capital One, while it's a diversified financial services company, it's built like a tech for the last decade. We have invested and invented the big tech companies. We are over 12,000 folks in the technology organization, 85% of which are engineers. We are all in on cloud like no other bank that's out there. We are also made a commitment to the open source community, declared open source first about a decade ago, and we have sponsored a lot of open source conferences as well as made contributions to many software projects. If you're interested, you can go check out at Capital One Tech or at Capital One Careers, and also follow us. Today's session, the agenda, we're going to be talking about the overview and significance of external data, orchestrating external data and the challenges, and then the strategies for efficient external data orchestration, and then a case study of how you can address the pain points and final conclusion. When a person is applying for a credit card, or it could be a loan, or it could be a mortgage, there is information that is provided by them. But in addition to that, some external data is also needed. So this would be some data that is needed for your identity verification. So this is needed by from through regulatory for being compliance with the regulations. And we want to check whether it's an individual customer or a small business is who they say they are. Fraudsters are always one step ahead. We want to make sure that there's no fraud activities going on. So it's simple things like checking address, phone number, email address, and then some additional fraud prevention can be done also with some of the digital data that you get along with the application data. And then finally, managing the risk. Once you get past through the identity and fraud, we want to make sure that the person who we are extending the loan or credit card would be able to pay back and use the external data for that. Orchestrating of these external data needs to be very reliable, efficient, and scalable. Reliability ensures that the data is accurate and is of high integrity, because a lot of the decisions that are made depends on this data that we get. So we want to make sure that fidelity is high. We also want to make sure that we can process this data in a quick, efficient manner. There is probably some SLAs with that you may have set up with your internal clients or with your partners, and we want to make sure that we are be able to meet those requirements by efficiently processing the data. Reliability, efficiency are very important from those aspects, and your applications also needs to be scaled. So you have launched a new product or some unexpected spike is there on there, then you should be able to scale your application to meet those demands. So, what are some of the challenges with orchestrating this external data? So, velocity, this is the amount of data that you're going to get, right? So, when you're going to make some calls to multiple third parties, there's going to be a lot of data that is coming in. So, how can you quickly and efficiently process this data? Quality of data is very important, as we talked about. The integrity, fidelity of the data is important, especially when you're using multiple data sources. How can you make sure if there are like issues or conflicts, how do you resolve them? Fault tolerant systems, it could fail anywhere. software, hardware, or on the network, how can we make sure that system is fault tolerant? Scalability, we talked about scalability. Our system should be able to meet the demands of the growing volumes. Privacy and security. So we are dealing with some of the most sensitive data here. So these are like a lot of non-public information, and we want to make sure that the data is properly protected, both in transit, at rest, and then meeting various regulatory standards on retaining of this data in a secure way. And then finally, the monitoring and management of that. Again, we want to make sure that all the various process steps of our orchestration is happening as expected, and if there is anything that is not working as expected, we get alerted through our monitoring that is in place. While there seems to be a lot of challenges with some thoughtful architecture design and using best practices, we'll be able to build that an efficient, resilient orchestration system which deals with external data. With that, I'll hand it back to Raja for some of those techniques.
Thank you, Thiaga. So now I'll be covering the efficient strategies for real-time external data orchestration. So the first thing that comes in mind is like parallel processing. So processing one at a time, may not be a good choice. Reason being, in most of the scenarios, there will be an time associated to make a financial decision, and in order to achieve it, we need to do that parallel kind of in a request or kind of in a fan out, so that we can go to the different vendors on the same point, get that data, construct that report, and return it back. But in some cases that may not be an ideal scenario as well. Like if the SLAs are really really strict, we may need to think about prefetching that data, so that instead of going out, we can get that data from the local store and make that decision. In that scenario, there will be a cost implication, and we need to make the right trade-offs between the cost and then the time to make that decision. Caching is like one step farther. Think about that. One client is actually coming for credit agencies or credit report, and then we get that data. If that client is coming at a later point of time for the same data, going out and get that data may not be feasible, because we'll end up having a double hit for that particular customer. So more or less, it's like a mandatory to save that data in our local store and get that data in order to serve that request. Automated exception handling. So failure is kind of, we need to think about that failure can happen at any point of time, and we need to build that system, thinking that something can go down, and how to handle that scenario, how to have that retry process in place. There could be an exponential retry to give some time to the third party vendor, so that they can come up and we can give a try to get that data. Or if the system is down for a while, we can think about an alternate data source to to make that decision in time. Moving on, dynamic scanning. There could be a campaign that is going on, and there could be a huge request that's coming to our infrastructure, and infrastructure should be resilient and responsive. So there should be an efficient scaling policy in place. And at the same time, when I'm talking about scaling, it should be like scale up and down at the same time, so that we also think about the cost while managing that huge surge at a given point of time. Data quality monitoring. The data is really really important, and something is not good, we need to be alerted, we need to monitor those kind of scenario. And this includes the sensitive data as well, right? If something is coming, we need to make sure that we check and validate that one or remediate that one. Standardization, giving an example, like vendor can go and do an upgradation from their side from version 1 to version 2. That should not have an impact to the calling client of this orchestration there. So if we have a data standardization, that should take care of that kind of scenario. Moving on, this is like a sample design that we thought about. It's not the actual real design, but while kind of coming up with the design, we were thinking what are all the basic simple components that is needed to do that the orchestration. So the left hand side is the calling clients, where it could be mainly of two nature. One is like the post, another is like get. So example, like someone is requesting for a credit report from credit agency one. We can get that data, store that data in our database, and then get can request for that data at a later point of time. The right hand side is the actual the third party vendor. So it's more often from that orchestration layer. It's like a network call, get that data and return it back. The top part is the data lake. When we are getting that data back from that vendor, we need to store it so that we can fulfill the analytical requirement or demand, and at the same time train our internal models. The bottom part is like monitoring or dashboard. If something is going wrong, we should be alerted and we should be remediate, both in terms of functional and from the infrastructure point of view. The central box, there are two components. One is the actual orchestration layer, that is the left hand side, and then the right hand side is the equivalent representation of the vendor within our infrastructure. And why I'm saying that one, so actual in the lowest layer, we need to form that request, and we need to process the response. The request could be very vendor specific, so we need to construct that one. And response is also very vendor specific. We need to get that data and process in that way. So for that purpose, that layer or that service layer is responsible to take care of that one. And we thought that having two different layer would help us to scale independently. um, Moving on, the orchestration layer and external data processing layer kept separate for efficient scaling purpose. All external reports stored in a database for caching and fulfilling regulatory requirements. Orchestration layer is configuration driven and can fulfill dynamic combination of requested data sources. And why I'm saying this one, let's say today we have 9 data sources that we have in our system to fulfill the client requirements. Down the line there could be 5 more that we need to add. So if it is configuration driven, we can achieve it in a low code no code mode. Real time streaming enable the data stored in data lake and in an for archival and analytical need. And when I'm saying the archival and analytical need, the operational store should be lightweight. It should not have the historical data which is not used during the real time. And at the same time, we need to move the data or historical data that is used in an archivable store so that we can fulfill the audit or some sort of similar requirement down the line. So monitoring support to check both business functionality and infrastructure health. And then operational and archival store, which I explained earlier, is separated for better efficiency, reduce cost, and fulfill regulatory requirements. Um, Addressing the pain points, efficient orchestration logic, caching, and right scaling policy helps to minimize latency, receive response data in a timely manner. Automatic schema validation and configuration driven data quality checks can be employed to manage the data validity and maintain data integrity across data sources. So when I'm saying that automatic schema validation, it could be an XST or something similar, so that it can be done in an efficient way on the fly when the data is coming into our system or going to the the third party vendors. Fault tolerance: the component of the orchestration should have limited blast radius and stay responsive in case of failure. Sensitive data, this is from our experience, it can happen at any point of time, because we do not control the data that is coming back from the third party vendor. If something sensitive is coming which we are not expecting, we should have a system in place to kind of check that kind of scenario and take appropriate action. If we do not take that action while the data is getting ingested in our ecosystem, it could be more costly. And then that's the reason we'd like to, or we recommend to have that system in place so that we can take that action when that sensitive data is coming into our system. Scalability: configuring the individual components to scale up or down in a cost effective manner. and operational monitoring. If something is going wrong, both in terms of business functionality or infrastructure, we should be alerted and take the appropriate action. Now, with this, I will now hand it over to Thiaga to cover rest of the slide.
Thanks, Raja. As you all know, just orchestrating business process has its own challenge. But when it has human interaction, it has system interactions. But when you add the dimension of external data, there are certain nuances and certain things that you need to be aware of. So we have shared our experience and some techniques that have helped us. So in this, hopefully you found this session informative. So thank you very much.